Hello there, welcome to CXC Math TV. Today we will be looking at simultaneous equations. Really nice. Alright, so of course we have to start with the $1,000,000 question. What is simultaneous equation? Well, to put it simple, simultaneous equation, it's simple, just two equations. That's it. Just two equations are given, and it's usually two unknowns. All right, two equations, two unknowns. That's it. Simultaneous equations, two equations, two unknowns. The most common variable that will be used is the variable x and the variable y. All right. Now, there are different methods that we're going to apply to solve simultaneous equation. And the two methods that we're mainly going to focus on in this video is the substitution method and the elimination method. All right. So when we say methods to solve the simultaneous equation, we means how are we going to be able to find the value of x and y that will satisfy both equations at the same time. And at the same time, hence, that's the meaning of simultaneously. All right. So for example, look at this question here. Solve the pair of simultaneous equation for x and y. 2x minus y equal 13 and 5x plus 3y equal to 38. Observe this. What if you were to substitute x as 7 and y as 1? 2 times 7 is 14. 14 minus 1 is 13, so the equation 1 is satisfied. Look at equation 2. Put in x as 7 and y as 1. We say 5 times 7 would be 35, plus 3 times 1 would be 3. And that is indeed equal to 38. So we observe that x equals 7 and y equal 1 satisfies the equation. And so therefore, since it satisfies both the equation, that would be the solution, or solution for this pair of simultaneous equation would be x equals 7 and y equal to 1. As we already said earlier, the two methods we'll be focusing on in this video is elimination method and substitution method. Let us start with elimination method. Now, the best way to do elimination method is to use an example, and then we'll write the rules as we do the example together. So this question says, solve the pair of equations for x and y. 2x minus y equal to 1, 3x plus y equal to 9. So, with the elimination method now, the first thing we need to do is determine the variable that we want to eliminate. We want to determine the variable that we want to eliminate. That's the first thing that we always do. So in this case, we will choose to eliminate y. So we're still in step 1 and we're choosing to eliminate y. In step 2, you're going to determine whether adding or subtracting will eliminate that variable you want. So we realize that, of course, in order to eliminate y, the best operation to do, that's what we're going to choose to both of these equations. Now, once you eliminate that variable, step 3, you then solve the remaining equation to find the other unknown. And step 4, we're going to substitute that value found in order to find the next variable. I know the step sounds confusing, but when we see it in an example, it will all make sense. So let's go. So here are two equations again. 2x minus y equal 1, 3x plus y equal to 9. And we decided that we're going to eliminate y. So we have the same number of y's in each case, and so that's why it's easier to eliminate y. So to eliminate y, because there's a minus y in the first equation and a plus y in the second equation, guess what we can do? If we add the equations, the y will disappear. So let's go ahead and add them. So we add the two equations, And so we add 2x plus 3x, that's 5x, minus y plus y, y's disappear, and 1 plus 9 equals 10. So that is step 2 completed. Now, we need to then go ahead and solve 5x equal to 10 to find what x is. In that case, we divide both sides by 5. And so what we're saying then is x must be 2. Once we get x equal to 2, step 4 now is we can substitute that value for x into either of the equations. I'm going to substitute x equal to into equation 1. So it's going to become 2 times 2 minus y equal to 1. And 2 times 2 is 4. And so it's 4 minus y equal to 1. But we know 4 minus 3 equal 1. And so y has to be 3. So our solution then is x equal to 2 and y equal to 3. And that is it. Really, really nice. That is all elimination method entails. So let's try another example. I want you to pause the video and attempt this question now. 5x plus y equal to 17 and 3x plus y equal to 11. Pause the video and attempt this question. Alright, so in doing this question, we notice that we have the same number of y's in the two equation again. So we can eliminate y. Alright, eliminate y because it's easier. Since there's the same number of y's and they're both positive, we would have to figure out now the operation that we have to do to get rid of y. But we realize if we subtract the equations, the y's will disappear. So in this case, we subtract the two equations. So subtracting 5x minus 3x, that will become 2x, y minus y, that's gone. 17 minus 11, that becomes 6. Now 2x equals 6, we need to find x, so we divide the equation by 2. In that case, x equal to 3. Once we get x equal to 3, we can substitute it into any of the equations to find y. I'm going to substitute it into the first equation. Now, hold up. You don't have to substitute into the first equation. Alright? I am substituting into the first equation. You could substitute into the second equation. But in the first equation, I replace x now with 3. So 5 times 3 plus y is 17. And 5 times 3 is 15. So the equation becomes 15 plus y equal to 17. And then 15 plus 2 is 17. And so y must be 2. And that's our solution then. So x equal to 3 and y is equal to 2. Beautiful. Really nice. Alright, let's look at a more challenging example. So this is a hard example here. So let us see. So solve the pair of equations for x and y. So the first equation, 3x plus y equals 10. 5x plus 3y equals 17. Pause the video and attempt this question. Alright, so in this case we notice that, well, there's a different number of x and there's a different number of y. And in order to eliminate a variable, we need the same number of x and the same number of y. So of course, let's label the two equations, equation 1 and equation 2. Look at this. What if we multiply equation 1 by 2? If we do that, we get 2y in equation 1. So we're multiplying equation 1 by 2. And so the new equation 1, you see that n1 that pop up? That's our new equation 1. It derived from multiplying the first equation by 2. So remember, the 2 times the 3 would give us our 6x. The 2 times y give us our 2y, and 2 times 10 give us 20. Then we'll write back down our equation 2. Now in this case, we have the same number of y's. So now we can eliminate y. Now since the signs are the same, 2y and 2y, they're both being positive, we can subtract the two equations. Subtracting the two equations, 6x minus 5x, that become x. 2y minus y, those cancel. And 20 minus 17 equals 3. So in this case, we get our x is equal to 3. Lovely. Now we can substitute x equal to 3 in either the first or the second equation. This time I'll put it in equation 2 because I don't want you to say I'm always substituting back into equation 1. So doing it in equation 2, 5 times 3 plus 2 times y equals 17, but 5 threes is 15. So 15 plus 2y equals 17. We can bring the 15 to the other side to say 2y equal 17 minus 15. And so in that case, y has to be 1. Because we know 15 plus 2 is 17. So in that case, we get to our answer that x is equal to 3 and y is equal to 1. And that's the hardest the question can come with elimination method. Nice. Now we're going to do this same question here, eliminating x, because I do not want you to leave the video and think that you have to always eliminate y. So look what I'm saying. You can make the same number of x in both equations. In that case, if we multiply equation 1 by 5, then we multiply equation 2 by 3, we get that the two equations are 15x. Let's do it. Multiply equation 1 by 5, that would become 15x plus 5y equal to 50. Multiply equation 2 by 3, it's 15x plus 6y equal 51. Remember, we multiply everything in equation 1 times 5. So 5 times 3, that's how we get the 15. 5 times y is 5y. 5 times 10 is 50. Then we multiply everything in equation 2 by 3. Okay, in that case now we get to our new equation 1. So n1 stands for new equation 1 and n2 stands for new equation 2. Since we have the same number of x's, we can subtract the two equations. So subtracting the equations, we're going to get 5y minus 6y is equal to 50 minus 51, which is negative 1. And if negative y is negative 1, then that means y must just be 1, right? So of course I didn't explicitly state it here, so I'm saying therefore y must be just regular 1. So then we can substitute y equal to 1 into equation 1. And so we're saying then that 3x plus 1 equal to 10. So in that case, we know 9 plus 1 is 10, so 3x must be 9. In that case, then x must be 3. And so that is our answer again, x equals 3, y equals 1. Look at it. In this method, we still got the same answer. If we go to the previous page, let's just go back around here, we still got the same answer. So irrespective of which variable you choose to eliminate, as long as you follow the correct procedures, you will be correct. And that's all there is to elimination method. Wow! Alright, now we go on to the substitution method. Now the substitution method is my preferred method because later on in math you'll find that chances are you're going to have to use the substitution method. Alright, so the substitution method. Let's start with this question here. We already know the answer because it's the same question that we'd have done earlier in the video with elimination method. You can pause the video and go back and look what the answer was, right? So this time now we're going to solve this equation using the substitution method. So let's go. To solve this pair of simultaneous equation using the substitution method, step 1. Decide on the variable you want to make the subject from the first equation or the second equation. It doesn't matter. We just need to choose one of the equation and decide which variable we want to make the subject. Alright, so let's call the first equation equation 1 and the second equation equation 2. Now what I'm going to do is from equation 2 make y the subject. Making y the subject, remember, all we do right here is subtract 3x from both sides. So 3x minus 3x, this would cancel. And so we end up get y equal 9 minus 3x. Alright? So this is how we got that y is equal to 9 minus 3x from equation 2. So that is step one. Step one out the way. We decided on which variable we wanted to make the subject from one of the equations. And we chose to make y the subject of the formula from equation 2. Now step 2. Step 2 now is you need to substitute the new equation that you got into the other equation. So remember, we were using equation 2 to make y the subject. So what we're then going to do is substitute this new equation for y into equation 1. We have to substitute it into the other equation. So we substitute 9 minus 3x into equation 1 for y. So let's go ahead and do that. So it's going to become 2x minus y. But when you plug in where y is, remember y is 9 minus 3x. So where you plug this 9 minus 3x in for y, it's going to become 2x minus in bracket 9 minus 3x, and that will be equal to 1. From there, you're going to just simplify. Simplifying, 2x minus 9 plus 3x is equal to 1. And then we add like terms. 2x and 3x is 5x. Minus 9 is equal to 1. We bring the minus 9 to the other side. And so 5x would be equal to 10. Then we divide both sides by 5 to get x is equal to 2. Once you get x equal to 2, step 3. Step 3 is then you substitute the value of the unknown found in any of the equations. So once you find x equal to, you can either plug it in equation 1 or plug it in equation 2 to find y. I'm going to plug it in equation 1. So 2 times 2 minus y equal 1. So 4 minus y equal 1. And so y is equal to 3. So in that case, we end up get x equal to 2 and y equal to 3. Beautiful. Nice. Alright, so I want you to pause the video and use substitution and do this question for me. Example 2. Pause the video and attempt the question. Alright, so as you pause the video and remember you had to use substitution method, let's go through this question now. So first thing, we identify the variable that we want to substitute for, right? So we're going to identify the variable and I'm going to choose equation 1. So from equation 1, let's make y the subject. So y would be equal to, we would bring over the 5x, so y is 17 minus 5x. That's what we're getting from equation 1. Now what is step 2? Step 2 then is you need to substitute that equation into the other equation. So we're going to substitute y equal to 17 minus 5x into equation 2. Let's go ahead and do that substitution. So remember, the second equation was 3x plus y. But what is y now? Y is 17 minus 5x. And that is equal to 11. So what we're going to do now is expand into the bracket. So we're getting 3x plus 17 minus 5x, but 3x minus 5x is negative 2x plus 17, that is equal to 11. Now we can then bring the negative 2x to the other side, bring the negative 2x over here, and bring the 11 over to this side, so it becomes minus 11 plus 17. All I did was bring the 11 over to the left side and bring the minus 2x over to the right side. But when I bring it to the right side, of course, it's going to then become positive 2x. In that case now, negative 11 plus 17, that's positive 6, is 2x. And so we just need to divide both sides now by 2, and that will give us x equal to 3. Once we get x equal to 3, remember we can then substitute x equal to 3 into any one of the equations. I will substitute x equal 3 into equation 2. So sub x equal 3 into equation 2. So we're going to get 3 times 3 plus y equal to 11. But 3 times 3 is 9. So in that case, we're getting 9 plus y equal 11. And so what we get is y equal 2, because 9 plus 2 equal to 11. So our solution then is going to be x equal to 3 and y equal to 2. Really, really nice. Lovely. Brilliant. Nice. Alright, so notice when we did this question, we didn't write any step 1, step 2, and step 3. This is how you'd want to be answering the question in an exam. You don't want to be saying step 1, step 2, step 3, step 4. Right? This is how you'd write your solution in a test.